Hi, it's Miss Andrews and Miss Conley again, and we have our last bit of our mixed review, part 3, our exponent laws. We have 2 problems to go over still. Oops. So this first one, we have a multiplication of our fractions. And remember that when we want to multiply with fractions, we multiply the top times the top and the bottom times the bottom to get our numerator and our denominator values. But before we do that, we always want to think about reducing fractions. And so if we look at this first term here, this first fraction, then we can look at the coefficients and the different variables to see if there's anything that we can reduce. So if we go through, and think about 4/6, that can be reduced to 2/3. And our a values, we have a to the second and a to the fourth, so that leaves us a to the second in the bottom. We have b to the third and b to the 1, that gives us b to the second in the top. And our c values are the same, so those are reducing each other out to a value of 1. In our second fraction, -3/9 can be reduced to -1/3. And then our variables, we don't have anything that's the same in the numerator and denominator, so they need to stay. Okay. So when we go through then and multiply the top times the top and the bottom times the bottom, that's going to give us our one fraction product. So if we look at our coefficients, we have 2 times -1 gives us -2. Ms. Conley, do you care which order we put the letters in?
Not really, but I usually put them in alphabetical order. So I would write the A first and then the B squared.
Okay. And then in the bottom we have 3 times 3, which gives us 9. And again, we'll go alphabetical. So A to the second, B, C to the fifth. And we can look at those pieces and see if there's anything to do to further reduce or cancel our -2/9. That's going to stay as -2/9. And then we have an a to the 1 in our numerator, a to the second in the denominator, so that leaves just an a to the 1, or we can just say a. For our b's, we have b to the second and b to the 1, so we subtract, we get b to the 1, we'll just write b. And we don't have any c values, so this stays c to the 5th in our denominator. So -2b over 9a c to the 5th. Okay, the next one that we have is a division problem.
Okay, so before we do the next one, we're going to just review quickly how we divide fractions. Remember, if you had 2/7 divided by 3/5, to do that you would multiply by the reciprocal. So we leave the 2/7 the same.
Keep it.
And then change the division to multiplication. And then multiply by the reciprocal, which is 5/3. Okay, so we would multiply by the reciprocal, and then we can just multiply straight across. 2 times 5 is 10, 7 times 3 is 21. Okay, so we're going to use the same concept, but notice we have much more complicated fractions now. So let's just rewrite that by multiplying by the reciprocal so we don't forget about that important step here. So we're just going to rewrite the entire first fraction, keep it the same. Okay, instead of division, we're going to do multiplication, and our reciprocal now is 9k m to the 6th over 4j to the 9th. Okay, so now that we've taken care of that, we can simplify it just like the last one. So if we look at our first fraction, 8/3, that you can't reduce that at all. They have no common factors, so we'll leave our coefficients the same. That's j to the 5th over j to the 7th, so we have more in the denominator. We're going to subtract, so 7 minus 5 gives us j squared in the denominator. That's k to the 4th over k to the 1st, so we do 4 minus 1 to get k cubed in the numerator. And then our m's cancel because they're both m to the 1st power. Okay, times. Okay, let's look at our second one. 9/4, no common factors there either, so we have 9/4. And none of our variables are the same, so we just have to keep everything as it is. Okay, so now that we've simplified, we can multiply straight across. 'So, So in the numerator, we have 8 times 9 is 72. And then in the denominator, we have 9 times 4 is 16. And then we have 4 times 6 is 24. And then we have 6 times 7 is 22. And then we have 6 times 8 is 16. And then we have 6 times 9 is 22. And then we have 6 times 4 is 16. And then we have 6 times 8 is 22. And then we have 6 times 9 is 22. And then we have 6 times 8 is 22. And then we have 6 times 9 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 is 22. And then we have 6 times 8 k cubed times k to the first is k to the fourth. We add those exponents, and m to the sixth. Okay, in the denominator, we have 3 times 4 is 12. J squared times j to the ninth, that's j to the 11th. So are we done?
Well, we still want to look at those coefficients and see if they can be reduced, and 72 and 12 have a common factor of 12. So that leaves 6 in the numerator, k to the fourth, m to the sixth, and it would be 6 over 1, but we don't need to put the coefficient of 1, just j to the 11th.
Okay, so really we just did 72 divided by 12.
Exactly.